For statics and mathematics.
It is for statistics one.
Okay, so all of you, have you completed the mocks? Yesterday's mock, have you all attended?
Yes, sir.
Yeah, sir.
How was it
Yes,
for?
I couldn't attend.
Okay.
I have a
How
doubt
many?
in mock, sir. I want to ask.
The mock session would be, I think, on Saturday. Okay, so you
Okay.
can till then you can keep on trying, like whatever. If you find out the solutions and see, ultimate thing is that you should try to solve it on your own, so that if you find any unknown questions in the exam, also it would be easier for you people. Okay.
Yes, sir. So one more thing I would like to ask, sir, where I can find the solution for the practice assignment? Is there a
Prac
solution for practice?
I think practice assignments, the solutions are already given when you
Practice assignment.
submit it. If you submit your answers, I think you can see the solutions to the answers, isn't it, for others?
Yes, sir.
Sure, the answer is there, but the way of how it is not doing is not there. The number is there.
Only
No,
numbers are there, sir. The way how to solve the approach, how to approach the problem.
No, sir, way is also there. If your question is wrong, then it will explain the way, or if you have entered some answer and it is right, then it will not show.
yeah, exactly. I think so that if you're writing wrong answer for anything, then it would show you the answer. I think the steps also, right?
Yes, sir.
Most probably that should be the case. Eh, you can just check it once. I think it would be there. But
Sir, are you going to revise or just doubt hearing?
no, we'll start revising from week 7.
Okay, okay.
Sir,
Yes.
sir, how much time will it take you to revise all the content from 7 to 8 week?
I'm not sure about it. Why?
Sir, I want to ask some doubts.
Doubts. It is if it is not related to means the doubts are from which? From
8th
where?
week,
No. I'm saying the question is from where?
8.6 activity.
Okay, activity question. Okay, so for that, one thing you can do, I think the best option would be to post it in discourse or in discussion forum. Okay,
Okay, sir.
that would be a much better option for you.
Sir, what time is the mock test discussion session on Saturday?
I think you'll get it on Saturday. Okay. Any more doubts? So most probably, I would suggest you all to join in tomorrow's session also, because it would be a PYQ one. So most probably, some of the important questions we'll try to solve it, so that you all are also familiar with the type of maybe what is the type of question that is asked usually, and then the mock session also you can attend. The, like what's the status of your preparations, everybody, like in general?
Sir, little less content.
Sorry, I think
What, sir? What did you ask?
like in general, what's the status of your preparation? Like how much have you all completed?
Sir, if you take mock as a reference, then on an average, I think we all got 7 to 8 or 9 questions correct.
Okay, and there were how many total questions in general?
15 questions, and it was 1 hour time limit.
Okay, so 15
Sir,
questions.
confidence is not coming.
Okay, these topics are a bit difficult. Okay, in general, someone who is doing this topics for the first time, it won't be easy. So the only thing that can help you people is practicing as much as you can. That is the only way you all will get
Sir,
enough
what happens during practice if some doubt comes, then the interest goes out, and when we stuck and nobody is there to
No, but we have
clear the
office
doubt.
hours daily, right? You can join those office hours and then ask your whatever the doubts are. There used to be office
Everybody
hours.
cannot.
Two to three
Everybody
times
cannot
we
attend.
try to join in office hours, sir, but no one is there in that.
When are you talking about the office hours?
Morning time. Yeah, office hours.
No, I think you would have joined in just today or yesterday, maybe, because only these 2 days it has been cancelled. Rest for all weeks it was running for every day.
Maybe yesterday I tried.
Yeah. For this week, because of we are having these revision sessions and this PYQ, so the morning sessions are not there. But other than that, whenever the running weeks were there, for example, when week 6 was going on, there was completely dedicated every day there were revision sessions. So,
Sir, when was the PYQ?
PYQ will start not today, it will start.
Sir, the mock quiz questions, sir, will they be discussed tomorrow?
Not tomorrow. I think you will get it in your calendar. Just wait for it. You'll get it.
Sir, only tomorrow is the class now. But next time the quiz is next time quiz will happen.
Next
Sir,
time
a
quiz
small-
will happen. Quiz is on Sunday, right?
So yes, sir. Quiz is on Sunday. A small doubt, sir. Can we expect mock type questions in the quiz too? I mean, will there be a lot of questions like mock, or some questions like mock?
See, this is very difficult to say, but yes, the difficulty level is, again, as I'm saying, that it is not means maybe you might have find difficulty in one question, someone else would not have find difficulty in that question. Okay, so it is a bit difficult to say that what would be, but yes, one thing is that if you all are preparing with your whatever you say that your assignments properly, and if you have gone through means enough practices, if you have practiced the assignment questions, and if you would have attempted all the activity practice assignment and graded assignment questions on your own, then I don't think it will be a bigger difficulty.
So for mocks, it was. I mean, I was able to do the mocks after trying couple of times, but getting all the answers correct on the first attempt was almost impossible. I think everybody was having issues with that. We were discussing that yesterday too. So can we expect similar type of questions in quiz too? Similar type of level.
Yeah, you can actually expect.
Okay.
Sir, is there any class on Saturday?
I think there will be a class. I'm not sure about it. So unless and until it's fixed, I will not be able to comment on that, but most probably you will have one. Okay.
Sir, I wanted to ask you again, sir. Mock quiz questions will be discussed after quiz 2.
No, why would it would be discussed after quiz 2?
Sir, when will they be discussed?
Just keep updated with your calendar. You'll get to know it. I am not sure about it. Either it would be most probably it would be on Saturday, or if it's if there is no class on Saturday, then maybe tomorrow one part of it would be with the PYQ and the other part would be with mock. Okay, but it
Okay,
would be discussed.
Okay, sir. Thank you.
Okay, so we'll start with the revision session. So basically, for week 4 and 5, what we learned was that we were trying to learn different ways of counting, right? That may be with the help of normal multiplication principle, or it can be normal addition principle, or we were trying to use permutation combination, and we were trying to find for different experiment what are the possible ways, or how many possible ways it could occur. That was the thing. But in week 6, what we started with is that one simple word, that is uncertainty. Now everything, whatever we are doing an experiment, there can be some uncertainty. Not every experiment you do you can you know the result of it. Like for example, you will come to give exam for your quizzes. You will not be for sure. You can't say that I will be getting this many marks in my quiz, right? So there is an uncertainty associated with everything. So that is what brings us to this topic, that is probability, which is used to calculate the uncertainty in an experiment. So in general, the formula that we'll be using is in simple number of favorable outcomes divided by total number of possible outcomes, right? So as I was talking about, the most important thing that we are concerned about is uncertainty. That what is the uncertainty, and in any experiment. So what is the difference between normal experiment and a random experiment? Any experiment where you can exactly predict the outcome, that would be a normal experiment. But if you can't predict an outcome and there are many possible outcomes from which anything can occur, then it is called a random experiment. That you are not able to exactly tell what would be the outcome, and you are solely dependent on there is some randomness into it. Anything can occur. So now when we are using probability, there are some tools that we have to be familiar with, or some mathematical terms. One is sample space, one is events. Anybody would like to say very quickly what is a sample space?
The number of all possible outcomes.
Yes, number of all possible outcomes. First thing is you should say that sample space is a set. Okay.
Yes, sir.
Under our statistical study.
Sorry?
Actual
Under
outcomes.
our statistical study.
Sir, set of all possible outcomes.
Set of all possible outcomes. Okay, but this there is one. There is one property, I think, which you should all be careful about, that it is exhaustive. What does exhaustive means? Anyone?
Means
Sir, it's union with
nothing,
sample space.
the complementary of sample
Sir,
space is
disjoint sets which
No,
have
no, no.
no things common.
exhaustive means, sir, nothing
Mutually
beyond
exclusive.
this.
Yes, sir, mutually
No,
No,
the
no.
union of all the events is equal to sample space.
Correct. Whoever said that, it is that exhaustive means that nothing, whatever you will note all the outcomes inside this sample space. Other than that, you can't have any other outcome for your
Complementary
experiment.
of sample space is 0.
You can say that also. Correct. You can say that also, that complementary of the sample space would be 0. But that is a very mathematical vague way to tell it. But yes, it is a correct meaning to it. But yes, if you have to say it in a layman's term, that whatever for a random experiment, what are the possible outcomes, all should be inside my sample space. You can't miss out any outcome. Okay. For example, if you are rolling a die, you know that all this 1, 2, 3, 4, 5, 6, these are all the possible outcomes, right? You can't say that my sample space can be just 1, 2, 3, 4, because you know that in a die I can get 5 and 6 also. So I have to note down all the possible outcomes. Okay. And events are it is also a subset of sample space, and which will include all the favorable outcomes that we are looking for, right?
Hello, sir.
Hi, yes.
Sir. Hello.
Yes, carry on.
Is this first revision session?
No, we had one yesterday. That was for week 4 and 5. Sorry, week 5 and 6.
Where can I find the link of that session?
You will get all in the YouTube only.
Okay, sir. Thank you.
Sir, outcomes will always be the subset of the of sample space. No?
Outcomes will always, yes. Outcomes will always be the subset of the
Subset
sample
of samples.
Correct. So event is basically, if you can say, I don't know how many of you have done maths, or you are doing it parallelly. So like you say, if you have to say events, we are talking about that it is a subset of sample space, right? So how many possible events can you define for one sample space? Anyone?
2 raised to n.
Yeah, it is 2 raised to n, right? Because if n is the cardinality of my sample space, then how many possible ways I can define my event? It would be 2 raised to n. Okay. Out of this, which events are favorable to me? That is a different case. Is this clear to all?
Yes.
Okay. So now
sir, can you repeat that again?
Okay, just I'll
2 raised to n.
2 raised to n is just that means if you have a set, let's say 1, 2, 3, 4. What is the cardinality of this set?
4.
Yes. So how, if I have to ask you that for, let's say this set is S, then I'm asking you that how many subsets can you form out of S? So that would be 2 to the power 4.
Okay. Okay. So each element can be or not. So each element has
Like
two options.
all the subsets can be, that way also you can say that, means if you have to prove it, how it is that it is that each element can be in my subset or may not be in my subset, right?
Yes.
Yes. So, and that is what we are carry forwarding for event definition of event. My event is also a subset. Now, how many possible events I can define on my sample space? That would become 2 to the power n, right?
Right.
Yeah.
Okay. So then the next thing which I was talking about, I think in general, like what are the favorable events you are looking for, or how you are defining a event, that is a very crucial thing. For example, let's say if whatever has been discussed in the lectures, I think this should be an interesting one, that there are 6 students who are running in a race. Now the order of finishing a race. So can anybody tell me what can be the sample space for this?
A, B, C, D, E, F.
1, 2, 3.
Sorry?
Factorial
6 factorial.
Yes, who is saying 6 factorial?
6 factorial.
Yes, sir.
Yes. So there is 6 factorial ways of define, means the cardinality of my sample space would be 6 factorial, right? Because these people, I can arrange them in 6 factorial ways, and that would be my order of finishing the race, right? And then if I have to ask that if I am concerned about an event where A is finishing first, then how what are the possible ways? Like what would be your event?
5 factorial.
5 factorial.
Yes, because I will, sorry, I will fix A first, and then I will be having, there are 5 more ways, sorry, 5 places to fill up the other 5 runners, and they can be done in 5 factorial ways. So if I have to ask you the probability for, so my event I am defining as, let's say the event is A, that sorry, not A, then it is confusing. Let's say small a is the event that A comes first. Okay. So over here, my probability would be
5
probability of
factorial by 6.
5 factorial by 6 factorial.
6 factorial. Yeah.
All clear with this one? So it would be 1 by 6 more, right?
Right.
Yeah.
Okay. Anyone any doubt on this part? Like this first top part is about how you will define our favorable events, and how you will define the denominator part is how we will define our sample space. Is this clear to all?
Yes, sir.
So can you please repeat?
Okay. So that the experiment says that there are 6 friends who are running a race. Now I'm saying that I need to find the probability of A finishing the race first. Okay, what is the probability?
In this case, we can simply divide 1 upon 6, means there are 6 persons, and coming first, A comes first. Is
I got it. What you're trying to say, that we are only concerned about the first position, so that can be filled in 6 possible ways, and my favorable case is only A becoming first, so 1 by 6, right?
Yes, sir.
You can do it. My whole motive is that just to how to define the sample space. That's why I'm trying to give the whole what are the possible ways, right? So that you can link it with permutation, whatever we have done last class. Okay. So basically, yeah, who was asking about the, okay. So as I was saying, that total number of sample space can be, if I have to ask you that what is the probability of A coming first in the race. So A can come first in the race. In this way, how many possible ways can you arrange?
6.
After fixing A,
Yes.
Factorial.
You will
5
fix A.
factorial.
Yes, and
5
the other
factorial.
places you can fix anybody, right? So it is 5 factorial ways, and in that in the denominator it will be total number of possible ways. So total number of possible ways can be 6 factorial, because all 6 can come in any position, right?
Yes, sir.
So that is how we are doing it, 5 factorial by 6 factorial. That is for the probability of A. Okay.
Yes, sir. But you were saying that 1 by 6, that's why I got it.
No, it is just because if you solve it out, then it will be 6 into 5 factorial, and top it will be 5 factorial, right? So you can cancel it out, it will become 1 by 6.
Yes.
Okay.
Yes, sir.
So next, what we will talk about, this is how you are denoting the sample space. Next thing to discuss in this is, okay, one more thing that can be confusing to people is mutually exclusive. Anyone would like to tell what is mutually exclusive events?
Yeah, sir. The intersection
It's
is
like a complement, na sir?
So which have nothing common in them.
Intersection is a null set.
Yes,
And
sir.
sir, when one occurs, the other cannot occur same time.
Yes, that is a better way to tell it, or maybe complement is also a good way to say it. But the most appropriate way is that when one event is occurring, the other event cannot occur. Then only you can say that those two events are mutually exclusive.
Okay.
So for example, very simple rudimentary example is that if you are saying that I'm tossing a coin is my experiment, then if head is occurring, then you can't say that in the same toss tail would also occur, right? It can happen in the other means if you take another turn and toss the coin, you can get tail, but in one attempt you will not get both at a time, right?
Yeah.
So that is how you can say that both the events are mutually exclusive. That is, if my one event is A, where I'm saying that I want to get a head, and another event, let's say B, where I want to get a tail, then these two events are mutually exclusive. That is, if I am getting head, then I can't get tail. That is what it means.
Yes.
Okay. So next thing is that, okay, guessing answer to a 4 multiple choice question. Okay, this is also, if I talk about, let's say what would be the sample space for this? That is, let's say you have a multiple choice question and it has 4 options to it. So what would be the sample space? The sample space can be any of the options.
Available options.
Yeah, any of the option can be the correct one. And if I have to say that what is the probability that option A is correct, then obviously the event is only A can be correct. So it is 1/4, right?
Yeah.
Okay. So now I think in this ma'am has talked about, okay, if just to revise it from the assignments, if I have to talk, I think there was one assignment question. I'll talk about that once, just give me a second. So let's say that you went to a shopkeeper. I think that was your last question or something in the graded assignment. That you go to a shop. Okay. Let me just give it a very small way. That you went to a shop, and in that shop, you are randomly choosing clothes of different types. Okay. Now in that shop, there are, let's say 5 shirts I will take. Okay, 5 shirts, and then pants, let's say 4 pants, and then let's say 10 say t-shirts. Okay, and you are randomly choosing one cloth out of this. So what is the probability that the randomly chosen clothes are of different types? Okay, so I think the question was 3 clothes.
Yes, sir.
That you are selecting 3 clothes. So what is the probability that you are the 3 clothes you have chosen, they are of different types? That is, out of the 3 clothes, one would be shirt, one would be pant, one would be t-shirt. How to do this?
5C1 into 4C1 into 10C1.
we have 5C1 into 4C1
5C1 into 4C1 into 10C1.
Okay. So it would be from the 5 shirts I have to choose one, from the 4 pants I have to choose one, and from the 10 t-shirts I have to choose one, right?
Yeah.
And in the denominator, what should I get?
19C3.
19C3. Okay. Now let's say if we'll change the same question, that what is the probability that you have 2 t-shirts and 1 pant?
5C2
4C1 upon 19C3.
So just tell me the numerator.
10C2
10C2 into 4C1.
10
divided by 19C3.
10C2 into 4C1. Correct. Now let's say I'm saying that find me the probability that there is no shirt in out of the 3. There is no shirt.
1 minus
14C3 by 19C3.
4C1 into 10C1.
Okay, one by one for this.
14C3 by 19C3.
Hold on. just one at a time tell me. I'll note down your answers, then we'll see, discuss it. Let's just before discussing it, let me write down what I'm asking. I'm saying that out of the three you are choosing, none of them should be shirt. Is the question clear now? Yes, tell me your answers one by one.
So 9C3
Sir,
upon
data.
19C.
One
Sir,
by
please write the data. How many shirts, how
Yes,
many
sir.
t-shirts?
okay, shit, I just okay, so I think it was a 5 shirt,
4 pants and 10
correct, yes, 4 pants and 10 t-shirts.
t-shirts. Sir, it will be 9C3 upon
Okay,
9.
you are saying 9C3 upon 19C3, right?
Yes.
Sir, may I, sir?
Yeah, carry on. One.
Sir, according to me, sir, 1 minus 5C3 upon 19C3.
1 minus 5C3 upon 19C3, right?
Yes.
According
to me, 14C3 divided by 19C3.
Okay, there are some people who are saying 14C3, 19C3. Okay, anything else?
Yes, sir. 4C1 into 10C2.
The 4C1 into 10C1 divided by.
Okay, this is another answer. 4C1 divided by
4C1 into 10C1.
That will
Okay.
happen
Divided
only if one pant and one shirt should come, no?
4C1 into 10C1 divided by 19C3, right?
Yeah.
My answer is that where you here you write 10C1, that is 10C2.
Sorry, whoever was talking, it's not clear. Can you just repeat it once more?
Here, which you write 10C1, write 10C2 my answer.
Okay, it is 10C2. Okay. Any more
Sir,
nuance?
it can be 4 shirts should not be there. Then it can be 4C2 into 10C1 plus 4C1
4C2 into 10C1 plus
plus 4C1 into 10C2
4C1 into 10C2
upon 19C3.
19C3. Okay. Any more new answers?
Sir, 4C3 into 10C0
4C3 into 10C0
plus 4C1 into 10C2
plus 4C1 into 10C2
Sir,
plus
are you solving for shirt
10C1.
or t-shirt?
None of them should be
None
shirt.
of them should be shirt.
Shirt. Then the answer like
Yes, sir. 0 part I missed.
14C3 divided by 19C3.
Sorry?
Then it also be 14C3 divided by 19C3.
Okay, this is what you are going with, right? No, out of whatever the answers are in the screen, other than that, any new answer, then you can.
Sir, I have to complete my answer.
Tell.
Sir, plus 4C2 into 10C1
10C1
plus 4C1 10C2
okay, 4C1 into 10C2.
That has been written.
This is written
It's
already.
already written.
Already written.
Sir, I have to add all these and after that I'll divide by 19C3.
Okay. Enough of options given. Now we'll move one by one. Let's say just starting with the first one, that is 4C1 into 10C2 divide. So we are all concerned about the numerator only. So whoever is saying 4C1, he's saying that one pant he will select, he or she will select, and 2 t-shirts, right? But this is not, this won't be the right one, because there can be cases where he will select only 3 t-shirts only, or maybe two pants and 1 t-shirt. So this part is not the right one. Whoever said this answer, is it clear why it is wrong?
Yeah, okay.
You have just consider one case, okay? That is why.
Okay, yeah,
okay. Next, coming to this complementary part, that is 1 minus 5C3. So 5C3 shirt. Okay. So this person has taken that. Let us consider that I am taking
all the shirts.
All are my shirts, and then I am subtracting it from the complement. Now in this case, when you are considering all of them, when you are talking about none, you can consider all. Okay. That is, but if you are saying none of them, sorry, all of them are shirts, and then you are complementing with that. Okay, this is correct. And
Sir,
for-
one minus all, it will be with no shirts. Answer will be no shirts.
Sorry?
How it can be correct if
Sir,
it is not
I am
including one shirt, it is including just all.
what I am doing is I am just selecting all the shirts and I am just subtracting it from the complement. So answer will be with pants and t-shirts. It will not be including shirts.
You're taking the case where all three are shirts, right?
Yes.
Yeah.
There,
Then I am subtracting.
but there are cases where only one of them can be shirt, two can be shirt.
all the
No shirts need
combinations
to
are
be
included.
selected.
Yeah.
Bro, no shirt needs to be selected.
No,
It
that
is
is where
given in
the
the question.
condition is given that none of them should be shirt. That's why it is okay. If it had to be given that at least one or something, then it would have been difficult.
Yeah, that is why, sir, none of them should be shirt. But here what a case is that he is including all.
Oh, shorts are not included in this.
Sir, yeah, 5C3 upon 19C3.
This is actually, yeah, correct. This is actually giving you all when you are subtracting. If this none case works, if it would have been given that at least one of them should be shirt, then you can just find out the none of them are shirts, and then you can
Yes.
get your answer. But
So
when you are
this is
doing,
incorrect.
if you are doing this case, actually you will be missing out those one or two cases where you will have that maybe one is shirt. Because what happens in this case, sorry, I just missed out that part. That for example, this is let's say if I have to explain it through Venn diagram, let's say this is shirt and this is pant, shirt, pant, and then there is t-shirt also, right? Let's say something, this is t-shirt. Now over here when you are saying that none of them are shirts, right? So what you are saying is that this part is not there, the whole this part. But there can be cases where he has taken one of them to be shirt and or two of them to be shirt. It will, you are just subtracting out only the three shirt possible case, and then you are doing it. But what about that at least maybe one is shirt or two is means out of the three we are buying only two are shirts. Okay.
Yes,
Means
sir.
there will be three cases out of this, that is one shirt, two shirt, or three shirt. But you are subtracting out only one, this one.
Okay,
But there
okay.
are these two cases also.
C1 should also be subtracted.
Yes, sir. Understood. Thank you.
So 14C3 upon or 19C3 is right? That
14
was my
C3.
answer. Yeah.
Okay, so again I just messed up. Okay, there were 5 shirts, I think, then 10 pants, and sorry, 10 t-shirts and
4 pants.
4 pants.
okay,
4
4.
pants and 10 t-shirts.
So for, and then this 10 t-shirts. So whoever are saying 14, 10 t-shirts, right? Okay, so whoever are saying 14, it's that you are considering only 10 pants and 4 sorry, t-shirts and 4 pants, right?
Yes.
Yeah, this is you can take it that and actually this is the way to do this, that you will just ignore this shirt wala thing. Okay.
Okay.
Okay, somebody who, okay, just hold on. If somebody has done it this way, the who was talking about that 4C3 pant, 4C3
Sir,
into
it's lengthy.
10C0. I don't know why you have done this. Okay, that you are saying that all are pants, and in this case, okay, yes, you can actually do this, but it doesn't make sense, like going to means in the
Lengthy.
lengthier method. Okay, but whoever is doing this, you can do this. It's not an issue. You can think it this way, but it's better to think in this perspective. Okay.
Yes, sir.
Yes, sir.
Sir, in that complementary one, was it correct?
No, because we were missing out 2 cases. That's why.
Oh, okay, sir.
Okay. One more thing. What is the difference between independent events and dependent events? Anyone?
In independent event, A intersection B is 5.
No, sir. In independent event, A intersection B is P of A into P of B.
In independent events,
PA plus PB equal to 1.
probability of one event doesn't affect the probability of another in independent events.
Okay, so someone who said this thing first, that A intersection B is phi, that is actually for mutually
Disjoint.
exclusive events or disjoint events. Okay, that if one event is occurring, the other event can't occur. That is for that case. Now coming to this independent thing, I think the next two whoever said it, it is correct that the occurrence of one event, if it doesn't affect the other event, then it is independent events. For example, just to say, if you are saying probability of A given B, if I will say that these two events A and B are independent event, then what should be my answer?
PA intersection B upon PB.
PA into PB divided by P of B.
I'm saying this.
A
Hold on.
intersection B upon PB.
Probability of A.
Hold on. I am saying A and B are independent events.
Probability
So,
of A.
okay, yes, whoever who said this probability of A?
I said so.
Okay, and someone was saying the other answer, what it is? Probability of A?
Into
A
PB.
intersection B upon PB.
This, right? Okay.
Yes, sir, but I am saying in the case when A is happening when B has already occurred.
A is happening or B has already, that is what the conditional thing we are talking about, that what
Yes,
is the probability of A given B. Okay.
Sir,
Probability of A.
explain, I didn't get it.
Sorry?
Independent and dependent events, sir. Can you explain?
So, independent events are the events where the occurrence of one event doesn't affect the occurrence of the other event. And dependent event is just the opposite, that the occurrence of one event will be dependent on the occurrence of the other event. Okay.
Sir, is there any example?
For example, let's say that there is a pack of cards and you are saying that I will pick up 2 cards. Okay. So the first card you choose and that has come out to be that, let's say, face card. Okay. So what is the probability that the next, and you are doing this without replacement. So what is the probability that the next card will also be a face card? So in this case, it is an dependent event because you have already chosen one face card. So when you will be choosing the next face card, you will have one less face card, right?
Okay.
So that way the occurrence of the second one is dependent on the occurrence of the first event. But independent event, let's say you giving an exam and your friend also giving the exam. Now the probability of, what is the probability of your friend passing the exam? Now your friend passing the exam doesn't depend on your passing, right?
Yes, sir.
So these two events are completely independent of each other. So now to write it in a mathematical form, I'm saying that if I'm saying that A and B are independent events, then what should be your answer for this conditional statement, that is probability of A given B?
Probability of A.
Okay, so there are two kind of answers. One is probability of
What
A
does this
and
notation mean, sir? Probability of A?
Probability of A given B.
A even B means?
No, A given B. Okay, so what does that mean? That means the event B has occurred, or the means if event B has already taken place, then what is the probability of A happening, the event A happening?
Okay.
So there is one set of answer that is saying probability of A, and the other set of answer is saying that probability of A intersection B divided by probability of B. How many of you think that the first one is correct, and how many
Both
of you
are
think
correct.
the second one
Yes,
is?
sir, both are correct.
Both correct.
Who is saying both correct?
I am, sir.
Sir, me also.
First one is correct.
Probability of A given B equals to probability A of A is for independent events, and probability of A given B equals to probability of A intersection B divided by probability of B is for dependent events.
Sir, P A intersection B in independent events will be equal to PA into PB. So if we put this in this equation, sir, so
Yeah,
PB
basically
will be
correct.
divided.
So whoever said that, this is actually my root equation, right, for conditional probability. Okay, so out of that we are deriving this part. How that comes out to be, just give me one second. Let's say when we are talking about, this is my conditional probability, that is what is the probability of A given that event B has already occurred, and the root equation for this is probability of A intersection B into divided by probability of B. Now, if we say that event A and B are independent events, then what happens? That numerator part becomes probability of A into probability of B, and the denominator part is already probability of B. So these two cancels out, and what we are left out with probability of A. So somebody who tries to solve the question with this, he will also get the answer. But the shortcut way is to do it by probability of A. Why it is? If you have to means not going mathematically, but just trying to understand the essence also. In general, what you are saying, that what is the probability of A given that B has already occurred, right? Now, if they're independent event, it means that it doesn't depend on B. So it can be directly said that it will be equal to what is the probability of A, right?
Yeah.
Because it is not depending on B. That can be one way to think about it, or mathematically also you can come to this conclusion. Okay. Is this clear to all?
Yeah.
Okay. The next thing what we are talking about is that I think these parts were already done. Okay, so I'll go to one more assignment question from graded only. Just a second. When independent and independent thing, that is, there was one question, if you all remember, that the chance that a student will clear the quiz 1 paper, let's say, give me one value, let's say 0.4, and the chance that he will clear both quiz 1 and quiz 2 paper is 0.3. Should I write this completely? Okay. The chance that he will clear quiz 1 paper is 0.4. The chance that he will clear both quiz 1 and quiz 2 is 0.3. The chance that he will clear at least one paper is 0.5. Okay, at least one is 0.5. So what is the probability that he will clear quiz 2? Anyone?
So we have probability A intersection B, where A is clearing the quiz 1 and B is clearing the quiz 2. A intersection B is.
Sorry, anyone trying to say something?
Sir, 0.2.
You're talking about the answer?
Yes, sir.
So PA union B equal to PA plus PB minus PA intersection B.
A union B equals to, this is all probability. Probability of A plus probability of B minus probability of A intersection B. This is what you're talking about?
Yeah.
Yes.
Okay. So the first thing, when you are talking about this notations, let's try to define all of the notations. Okay. So A union B, what does that, anybody, can you tell me physical significance of A union B?
At least
A.
At least
Or
one of
at
the
least
papers is
B.
cleared. At least one of the papers.
One of them, yes, sir.
Okay, so at least one of the paper says A union B. This is quiz 1 cleared, this is quiz 2 cleared, and what does A intersection B tells me?
Both of the papers.
Both of the paper cleared. Okay, so over here what we are given, quiz 1 and quiz 2 is given, that is 0.3, right? And for quiz 1 it is given 0.4, and for the this probability of B, that is what we want to find out, correct?
Yes, sir.
So let's say this is X, and then is A union B given to us?
Yes, sir. 0.5.
That at least part is giving us 0.5, that is A union B. Because when you are talking about at least, it means that either it can be A or it can be B, event B, or it can be even both also, right? So then it is basic algebra. Anybody who didn't get this part?
0.4.
Anyone who didn't get this one?
No, sir.
Okay. So now let's say, if I have to say that A union B is at least one of them, at least one of the quiz is passing, right? So what would be the physical significance of A union B complement?
So neither
One minus A union.
One by one you can say.
Neither quiz 1 nor quiz 2.
Neither A nor B.
Neither. Okay, one person is saying neither A nor B. Any different answer? Then you can say. Or everybody is agreed with this answer only.
Yes, sir. Neither A nor B.
This is correct.
Okay, so it is that neither A nor B it would be, right? So next thing which I wanted to discuss from this part, I think this mutually exclusive we have talked about.
Sir, what is the answer of that question?
I'm not sure about the answer. I just
0.4 it is.
Yes,
Four,
sir.
right?
Point
Okay.
four.
Yeah, thank you.
0.4.
Okay. Okay, so conditional probability. Okay, one more thing is we'll talk about the implications of Venn diagram. Okay, just give me a second. So if there can be questions where you have to solve it through Venn diagram. So there was one more again the same way. There was one question we'll try to solve that in graded only. Just give me 1 second. Okay, there are total n students. Let's say I'll put, give me a number. Let's say 150 students. Okay, let's say there are 150 students in a class, and out of that there are people who play badminton, and there are people who play table tennis, and there are people who play just tennis. Okay, and out of which, let's say for the table tennis, 50% of students 50% of students play table tennis. 50% of students play table tennis, and normal only tennis is, let's say, 20%. Okay, I want each of you to solve this one. Okay, then we'll discuss it out. And let's say badminton is 70%. 70% is badminton. So just I'll write it below only. Badminton, 20% is tennis, and 50% is table tennis. Is this clear to all?
Yes, sir.
Yes, sir.
So what we have to answer in this question?
So what is the question?
Now a student is selected at random. What is the probability that he or she is the part of the table tennis team? Okay, there is one more part to this question, that it is noticed that all the students who play tennis also play table tennis, but not badminton. This is a very crucial part actually, which may be confusing for people, that all students who play tennis also play table tennis. This part will actually change your Venn diagram in a different way.
What is first question, sir?
Sorry,
What is first question?
the question is only one question. This is these are the conditions, that there are 150 students out of the who are playing badminton, table tennis, and just tennis. 50% of students play table tennis, 20% of students play tennis, and 70% play badminton. Now
Yeah.
we are saying that all students who, there is a condition given that all students who play tennis also play
Yeah.
table tennis, but not badminton. Okay.
Not badminton.
Okay. Now you are choosing one student randomly. What is the probability that he or she is a part of the table tennis team?
Okay, sir.
Anyone, any more doubt with the question? Okay, just try it 1 minute. I'll start discussing. Don't need the answer. I just need the Venn
Hello,
diagram.
sir. May I? Sir, actually, if it would be very nice if you could share the screen or the question, because it's not really very much understandable with this.
Okay, I'll just write it down. Maybe I don't have the question with me as of now. Just give me a second. There are 150 students, then 50% play table tennis, 20% play tennis, and there are 70% who plays badminton. Okay. Now we are saying that students who play.
So do we have to give the answer or the Venn diagram?
Just the Venn diagram.
Done, sir.
Students playing tennis also play table tennis. So tennis equals students who are in the tennis team also play table tennis. Okay. But not badminton. So what is the probability that you choose one person and that person is a table tennis player? Okay, just anybody who has completed it or is thinking about the answer, can you tell me how many?
Yes, 1/3.
Okay, 1/3 is the answer you're saying. That I'm not sure about the answer. Okay, we'll see. Just give me a second. Just first tell me what should be the circles, like how many concentric circles I'll be making?
So there will be one circle for TT and another inside it for table tennis and another for badminton.
You are saying something like this?
No.
No, sir.
But
Two
you can make
intersecting and
another.
one alone.
Okay,
Yeah, one.
there will be intersection these two, right? What would be
Yes.
these two circles? What would be the left one?
Badminton or table tennis.
Okay, let's say put table tennis, and this part is, let's say, badminton. Okay.
Yeah, make another one in table tennis for
Smaller
tennis.
circle in table tennis.
One by one. Can you just any one of you? Yeah, can continue.
Tennis is a subset of table tennis, sir.
Because this part, if you see, that students who are playing tennis are also playing table tennis, right? So that means you have to go by the wording of the question, that students who are playing tennis are also playing table tennis. So it means that all the tennis players play table tennis, but there can be players who play table tennis but not tennis. Is this part of the question clear to all? So basically my tennis circle has to be inside this. That is, that people who are playing table tennis, like let's say one person over here, he is not playing actually tennis, but every person who is playing tennis automatically is also playing table tennis. Is this clear to all?
Yes, sir.
Or anyone,
Yes, sir.
anyone who didn't understand this part? Okay, then rest parts are very normal. Okay, it's just that we have to put out the numbers. That is, whatever the numbers are, just 50% students of TT, so you'll take 50% of 150, 20% of 150, and 70% of badminton, and just put them in the whatever the numbers are inside the circles. My only motto was to just tell you that what should be the three circles. Okay, so it is very important just you note down the wordings of the question very clearly. If it would have been given that students who are playing table tennis also play tennis, it would be the opposite of this, right? Students who play table tennis also play tennis. Then it should be that your the bigger circle would become tennis and the smaller circle would become table tennis. Is this clear, na?
Yes.
Sir, here question is only tennis, no? Only tennis or tennis players simply?
Sorry, I didn't get it.
Means only tennis, not other games. Is it like that?
No, it's just an example I'm giving, that according to the wording of the
No,
question.
the question, the student.
Okay. You are saying those who are those who are playing tennis, are they playing other game or not, right?
Yes, sir.
They are playing table tennis also, but not badminton. That is what is given, right?
No,
Maybe
in question, finally, what the question is asking means probability of selecting a student who is playing tennis, who is playing table tennis.
For this question, you are saying?
Yes, sir.
The probability that you are choosing one person and that person is playing table tennis. Only play table tennis.
Only, not other games.
No, not other games.
Oh.
What is the final question, sir?
Final question is this only, that you choose a person randomly. So what is the probability that that person is means playing only table tennis, nothing else.
Okay. So then it will be 1/10.
Yeah, it would be something 1/10.
Yes, sir. Yes.
Okay. So basically you will take only this part, right? If I have to said it, then this is the part we are concerned about, right?
Yes, sir.
Is this clear to all now? Like means how to put into wordings normal this question. So basically there can be your Venn diagrams can be this kind of, that you are having 3 intersections or one circle would be inside. This could have been another variation for this question. Let's say if I have to go draw it again, just that this part was for table tennis, and this part is for say it was not badminton, and this small circle, whatever we were doing, let's say that small circle is also intersecting with this bigger circle. Okay, means the circle of this part. Can you tell me when this would happen? I did it wrong. Just a second. It would be something like this, for example. Only intersecting. Can you tell me when this would happen? And
When
this is
the
tennis
tennis players can
all
also play
tennis players.
badminton and table.
So the question would change that all tennis players are also playing table tennis, and they can also be a part of the badminton team.
Some are playing badminton also.
Yes, some of the tennis players are playing badminton, and but all the tennis players are also playing table tennis also, right?
Yes, sir.
Okay, so I think that would be enough for the Venn diagram thing. Now normal, one more thing, you should always be careful that you may know the answers, but you have to keep a track of how many face cards are there in a playing card, how many there are
Face card
3 face
in each
cards.
suite.
Sorry, one at a time.
Total 12 face cards.
So for one color it is 3, right?
Yes, sir. That's
Oh, 6. One color it is 6.
Sorry, yes, one shape it is 3, and for one color it is 6.
Yes, sir.
Yes. So be careful of those things so that you don't mess it up. You may be knowing the answer, but just because of counting it differently, you will mess it up in the question. Okay. So that is one thing. And then I think the graded assignment for a conditional probability was in week 8 or week 7.
Week 8, sir.
Week 8.
Okay, so the union properties, I think that is done. If just to reiterate it, one thing is the complement, that is probability of A would be 1 minus probability of A. If you have to give an probability of A union B, okay, there is one more, I think somewhere you can use this, the De Morgan law. That is, let's say when we were talking about the earlier question, right, that for example A union B says that either A would be happening or B would be happening, and if I have to say neither A nor B is happening, then I will talk about A union B complement. A union B complement, right?
Yes, sir.
Yes, sir.
So when we are talking about A union B complement, I can write it according to De Morgan's law by probability of A complement intersection B complement. Okay, so be careful about this also. This can help you in solving some of the questions.
Sir, last part, what did you say? I didn't get it.
It is just the De Morgan's law that says that if, for example, it is given A union B complement, in some question, there may be a case that you are just concerned about, let's say this was my circle, sorry, the whole sample space, and this is one event, this is one event, and let's say this whole thing is A union B, right?
Yes, sir.
Maybe this event is that you passed in quiz 1, this event B is that you passed in quiz 2. Now if I have to find out an answer, that what is the probability that you failed in both the quizzes. So you can sorry,
nothing. Gone.
so what is the probability that you failed in both the quizzes? So it would be A union B complement, right?
Yes, sir.
That you can actually find out just if you can find out A complement intersection B complement. Okay, so maybe the way to do it would be that you go for, if they're independent events, you have to just multiply them. If they're dependent events, then you will find out A complement probability of A complement plus probability of B complement minus probability of A complement intersection B complement. Okay.
Okay, sir.
How to find the answer of that previous question?
Sorry.
Sir, how to find the answer of that previous question which we did? Which answer was 1 upon 10?
1 upon 10. You just just wait.
1 minus BD.
You will have something like this, right? So
Yes,
you will have some intersection part. Just from that, whatever the number is, you have to just divide out, separate out that this part would be there. This would be, you will get one which is inside this only, and you will subtract out this common part. Then you will get exclusively for this part the numbers. Then that would be your answer.
1 minus BD minus this tiny circle part.
1 minus BD.
Yes, sir.
Means whatever it is, the answer means BD part was, I think,
0.7.
0.7, right? So 0.7 of 150.
Yes, sir.
And that would come out to be, I think, if you have about 15 into 7, I think 105.
105.
10.
So we can do like 1 minus 0.70 minus 0.2, which is of the table tennis or tennis, and it will come out to 0.1. We can
Okay,
do
yeah.
also like
Okay,
this.
you are saying not to take the values, you will directly do it in percentage, right?
Yes, sir.
You can do it, doesn't matter.
Okay, sir.
Okay, so that was another part to it. I think anything is left from week 6. Okay, this is one
answer in that case is 0.1, na, probability.
Yes, the answer to that is 0.1. So this is one question we'll discuss about, that a student has 40% chance of receiving an A grade in statistics, 60% chance of receiving an A in mathematics, and an 86% chance of receiving an A in either statistics or mathematics. Find the probability that she doesn't receive an A in either statistics or mathematics. Just tell me in the set notation way that what are we looking for?
A union B complement.
Yes.
Intersection.
Yes, sir.
Sorry?
Complement, intersection B complement.
Whoever is saying, just tell it clearly and please one by one.
Question is asking to find out A union B complement.
Okay, you say you are saying that it is saying A union B complement, right?
Yes, sir.
Okay. Anyone else?
A union B complement.
Intersection B complement.
Sorry?
A intersection B complement.
You are saying A intersection B complement. These are the two answers, or anything else anybody has?
No.
No, sir.
Okay. Well, whoever is saying A union B complement, why? What is the logic behind it?
So since it is
Either or.
intersection B complement, so according to De Morgan's law, it should be equal to A union B complement.
Sorry, I didn't get it. Can you just please repeat once?
Since we want to know neither A, neither B.
No, it is
Or.
given either statistics or mathematics.
Sir, it is given or. Sir, in
Yes,
case
no.
of both
So-
and we use intersection.
This is this question, just to clarify, it says that does not receive A in either statistics or mathematics. So maybe in statistics he can he or she can get he or she doesn't get an A, or in mathematics he or she doesn't get an A. It is not said that means both in statistics and mathematics he or she hasn't got an A. Are you getting it? The difference?
Does not receive
does not receive an A in either statistics or mathematics.
That is, there is no A in
statistics, there is no A in mathematics also. It's like that, right?
So it is same as neither in statistics, not in mathematics. No?
Yeah.
No, when you are saying neither in statistics nor in mathematics, then it is compulsory that you will not be getting an A in both the subjects, right?
Yeah, it's the same, right, sir?
No, when
Does
you're
not
talking about
receive either in A or in mathematics. So does not receive in A, does not receive in mathematics also.
So you can write A complement intersection B complement.
this is for what you
A
are saying.
union B complement.
They are saying
A
A is
union
common
B
in both.
So first one is correct, sir. A
They
union
are
B
saying
complement.
Yeah,
they are saying A is common in both.
One, I need answers one by one.
So A
Yeah,
union B complement can also be written as A complement intersection B complement.
A union B complement can be written as A complement intersection B complement. Yes.
But it cannot be written as A intersection B complement. So that's the case. Second point is, I guess, wrong.
Yeah.
Second point, that is this one you are talking about.
Yes.
A intersection B complement is not correct. Union
Okay.
B complement is correct.
You are saying A union B complement, right?
Yeah.
Let's see what
Think
ma'am
so.
has. This is what we are trying to find out, right? Why A intersection B complement doesn't work? Because
Or condition.
So because there is not.
yes, there is basically this is the main culprit, that because it is given or. When we are talking about intersection, that is that we are saying that this and both the events are taking place, right?
Yeah.
Sir, I didn't get it actually. What is meaning of does not receive an A in either statistics or mathematics?
So
I'm
see,
still getting it as neither in statistics nor in mathematics.
Yeah.
It is different from that.
Sorry, I didn't get it. What are you saying?
Sir, I am interpreting it as he does not receive an A. He receive an A neither in statistics nor in mathematics. Is it not the same as what is written here?
What is written over here? It means which line you are talking about? This line you are talking about?
The one line, sir, for number one, does not receive an A in either statistics or mathematics. So is it not same as he received A neither in statistics nor in mathematics?
Okay, you are saying that English wise are the both the meaning same or not, right? See,
Yes.
first
Neither or
thing is,
neither nor.
first thing is, okay, just see, if you have to write it this, when you write it in the complement form, it becomes easier. Just a second. Okay, so when you are writing it in this way, it is not that interpretable, rather than if you write it this S complement and N complement. Okay, now tell me, what does S complement mean?
As complement means receive
Neither statistics.
Not statistics.
No, neither is not the word to be used over here. When you are saying just S complement, it says that he is not receiving an A grade in statistics, right?
In static, right.
Yes. And when you are saying M complement, that person is not receiving an A grade in mathematics, correct?
Yes, sir.
Now, when you are saying intersection, it says that and. So, what does actually this the meaning of this is that you are not receiving, means that person is not receiving an S grade in A grade in statistics, and he is not receiving an A, means he is also not receiving an A grade in mathematics. That's it.
Is
this
not
clear?
getting it. No, sir, this is not clear for me. Yeah, it is still I am getting it as neither. So it is.
No,
can you explain why Venn diagram?
Whatever you are saying, that is actually the correct. That you are saying that I think you said neither or something.
Yes, sir.
So in general, what are you trying to say? That he is not getting an A grade in statistics, and he is not getting an he is not getting an A grade in mathematics, right?
Yes, sir.
That's what you are saying. Sorry.
So whatever you have written here is S intersection M complement is equal to S complement intersection M complement. So it is correct.
This is what we are talking about. This part, that when you are talking about S intersection S complement intersection M complement, it actually means that that person hasn't gotten S grade, sorry, A grade in statistics, and
Yes.
he hasn't gotten A grade in mathematics. Or you
Yes,
can
sir.
say in English that neither he has gotten A grade in statistics or mathematics.
Yes, sir.
These are all the same things. You are just putting it in different words.
Okay, and the left part is what it is written here, does not receive an A in either statistics or
See,
mathematics.
over here what we have defined S, that is important. Over here S is said, S defines that he is getting an A grade in statistics, and M says that he is getting an A grade in mathematics, right? These are the events. So either when you are talking about this S union M, it says that either he is getting an A grade in statistics or in mathematics. Okay, means, or you can put it in this way, means whatever, if you have to say it, that S union M says that in at least one subject he is getting an A grade. Okay.
Yes, sir.
Now when you take the complement, it becomes that in none of the subjects he has gotten A grade, right? And that is actually equal to that in neither in statistics nor in mathematics he has got A grade. These are again the same thing, right?
Okay, okay. So, sir, this is correct for all conditions or only for this question?
What condition? I didn't get it.
This S union M complement means A union M complement, A union B complement.
This this is correct in all conditions. That is through De Morgan's law, you can write A union B complement always as A complement intersection B complement. Okay.
Okay.
Always it will be same, because English wise I am saying that it is the same thing, that when you are talking about that at least one of them and you are taking its complement, it becomes none of them, and that is equal to neither of them.
Okay, sir.
Okay.
Okay, sir. Okay, sir.
That is just the solution part to it. I think that's it for are you missing out anything from week 7?
What about the second one in that, sir?
Uh,
Second one,
Sorry, just give me a second.
same question.
You're talking about this receive A in both statistics and mathematics, right?
A intersection B, right?
This is just normal A or S, whatever it is, A intersection B, because that was our main event, right? Once you define the events, then it becomes very easy. Is this clear?
Can you show us the answer? I mean, the answer is right.
This is you're talking about S union complement, so it will be 1 minus S union M.
Okay.
And this second part is S intersection M, which you can write it that way. Okay. It's clear to all?
Yes, sir.
Okay. So that's it for okay, one more thing is that the term equally likely outcomes. So what does equally likely outcomes mean, anyone? In general, when we are talking about equally likely outcomes, it means that all the outcomes has the equal probability of, sorry, it is not biased, or all the outcome of means each outcome is equally probable. Okay.
Yes.
So you can receive this in questions, that let's say it is said that there is a fair dice, or maybe a fair coin, or a unbiased coin. These are the terms that says that all the outcomes are equally likely in that case, right? It just different ways to answer, means put down the question, but ultimately it says that all the outcomes are equally probable. Is this okay? Okay, there is one more question I wanted to discuss in graded. This is one more question which will kind of relate you to the permutation combination thing, that there were 2 girls and there are 8 boys. Okay. And now we are saying that in what is the probability that there are exactly 4 boys in between 2 girls.
So we will fix the two girls like and make the gap.
Where
Can
will you
you repeat the question?
there are 2 girls and 8 boys, and I'm saying that what is the probability that there will always be 4 boys in between 2 girls?
This is linear arrangement, no?
Correct, it's linear arrangement.
So we will make the 4 boys as one unit and 2 girls like they are
Sir, we will make
different.
4 boys and 2 girls as a one unit. Then we will find.
You'll take 4 boys and 2 girls as one unit, okay?
Yes, sir.
Then what happens?
So then we will find, sir, number of.
But
it won't work.
where will you put this? Like for example, let's say you have taken G1, this is what you will do, right? You are saying 4 boys, B1, B2, B3, B4 and G2, correct? This
Yes,
as one unit, and then they will be arranging among themselves, right?
Yes, sir.
But why are you restricting any 2 girls? That can be any, the other girls can also come in these places, na?
The arrangement of girls will be 2 factorial. Arrangement of girls will be 2 factorial. That is initially decided.
Yes, sir.
The arrangement of 2 girls will be the arrangement of the 2 girls will be in 2 factorial ways. But these 2 girls, where will you make them sit? When you are talking about this, that they are one unit, they can arrange among themselves. You are considering or not?
Yes, sir.
Yes, sir.
No, but if you are starting to consider the arrangement among themselves, then you will mess it up, right? Because you have to then take it separately, that G1, G2 would happen 2 factorial and this would become 4 factorial. This is what you are saying, right? And in general, this is one unit, and in this 4 boys has already been taken, so this should be 5 factorial. So ultimate answer is this, what you are saying, right? Or anyone has
No,
some
sir.
other answer?
Boys can be B1, B5, B6, B7 also.
Okay, so
those who come in between. So
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 that
what-
we can select 4 boys out of 8, na? So 8C4, we can just do that.
Okay,
Sir?
so you yes.
So 2 factorial into 8C4 into 8P4. We can do things like this.
So what should be in the numerator? Just tell me that.
So 2 factorial into 8C4 into 4.
2 factorial into 8C4
C4 into 4 factorial.
Into 4 factorial. This is what you are saying?
Yes, sir.
2 factorial is for the girls.
Yes,
Selecting
sir.
the boys is 8C4 into 4 factorial, right?
Yes, sir.
And what about the other 4 boys?
I didn't take them. Sorry, sir.
Multiply that by 4 factorial.
Multiply that by what would be 4 factorial. One more 4 factorial.
Likewise, so we have only chosen 4 boys, na? So that's it.
No, the arrangement
Girls
is that
can be arranged.
4 boys should
8
be in
boys are
between
there.
the girls, in between the 2 girls, but that doesn't mean that the other 4 boys won't be there, right?
Okay.
Yeah, I think this is correct, sir.
Yes, so then this will be the
And in the denominator, what should be there?
12 factorial. No, I mean 10.
Sorry?
10
factorial.
C2 multiplied by factorial 10.
No, it's just 10 factorial, right? You don't need to do anything else.
Yeah, yes, 10 factorial.
Is this clear to all?
Yes, sir.
Can you explain, sir? Can
no,
you
sir.
explain?
Yeah, I'm totally confused. If you can explain it.
Which part?
The whole thing, actually.
Okay, so the thing is, the question says that there are 8 boys. There are 8 boys and 2 girls. Okay, and we are talking about arranging them in such a way. What is the probability that in between the 2 girls there will always be 4 boys? Okay, so how many possible? So what is the probability of doing that? So now what we can do is that you fix the two girls, and then in between the two girls you fix the boys. Now those boys can be that out of the 8 boys you choose any 4 boys and put them inside, and then you put them into a into one bundle. So what happens is that once you put them into bundle, those 4 boys can also arrange among themselves in 4 factorial ways, and the 2 girls can arrange among themselves, that is alternate. Okay, this can C can come over here and C can go over there.
Yes.
So that can be done in 2 factorial ways, right?
Okay.
And the other part can be the rest of the 4 boys can arrange themselves in 4 factorial ways. Is this clear?
Sir, what is 8C4? 8C4.
8C4 is choosing 4 boys who would be in between the 2 girls. That is 8C4.
I had a
Yes.
so for the rest of the boys, you're saying it's 4 factorial, right?
Yeah, there I also have.
Why won't it be 5 factorial? Because the bundle itself can move,
Yeah,
right?
yeah. That should be 5 factorial. Even I feel.
Okay. Yes. Sorry. Yes, it would be 5 factorial. Sorry. It would be actually 5 factorial because
4
of the
boys and the
other 4.
bundle.
Yeah.
Yeah.
Yeah, it would be 5 factorial. My bad. Yes.
Sir, 4 boys are not always same. Then how we can bundle it?
No, that's
The
why
rest 4
that's
can
why
also come.
that's why that is encounter from this 8C4. Na? That first you will be choosing 4 boys out of this 8 boys and then put them inside the box. It can be any 4. Okay, let's say B2, B3, B4, B5, any 4. And then the G1, G2 are always there. And rest of the boys will interchange with this bundle. For that is the 5 factorial part. Okay.
Yes, sir. Thank you, sir.
Sir, we can treat 2 girls and 1 bundle 3 and rest 4 boys, total 7. So we can do like that also. So arrangement of 7.
I didn't get it. Can you just tell me what one?
Sir, we are bundling 4 boys and we can take it as 1 unit. And 2 girls are there, so 3, and plus 4 more boys are there, so 3 plus 4, 7. So we can
you are bundling 4 boys 1 unit.
Yes, sir.
And 2 girls as another 1 unit.
Yes, sir.
And then 4 more boys as normal 4, right?
Yes, sir.
So then also it becomes 6 factorial, right?
5. So
this is 4.
7
these are 4 people. 2 girls you have bundled as 1 unit, and this 4 boys as 1 unit. So 4, 5, and 6. Huh? Why are you saying 7? Means how it is 7?
No, sir. 2 girls are different, no?
So you are bundling them, you said, right?
No, I'm bundling only boys.
Okay, so these 2 boys, sorry, the boys are 4 boys as 1 unit.
Yes,
2
sir.
girls would be separate and 4 boys would be separate, right?
Yes, sir. So
No.
factorial 7 can be
No. The thing is
7 multiplied by 8C4. That can
no. This won't happen because ultimately we want the girls to be on the extreme positions and the boys has to be in between them. So you have to bundle them all together.
Yeah, 6 of them will always be together.
Yes, and that has to be in a fixed way, which way you want it. If you do it separately, then what happens? These 2 girls will arrange among themselves and the boys will arrange among themselves. So you will not have you will not be able to maintain the order that you want.
Okay. So we can bundle it like that and
bundle it like that means
whatever you told, sir. 4
yes,
plus
you will
2, 6 and rest 4.
That's why it will be 5 factorial. The 4 boys, G1, G2, and then rest 4 boys, B1, B2, B3, B4, sorry, whatever it is, B4. These are the 4 boys, and this is 1. So this is 5 factorial.
So 5 factorial multiplied by 8C4.
Huh?
This is the total ways, no, sir? Only.
No, 8C4. Then this these 4 boys can also interchange among themselves, na? 4 factorial. These 4 boys, you have put them inside, but they can also interchange. Like for example, G1, B1, B2, B3,
Yes, sir. Yes,
B4.
sir. Okay. So 8C4, I am saying for that only, sir. 8C4.
No,
Okay,
8C4 won't consider the arrangement among those 4 boys, right? It is just selection of 4 boys out of 8 boys.
Yeah, 8C4 multiplied by 4 factorial. Okay.
And then again the girls interchanging among themselves,
Into
that would
2
happen in 2 factorial.
Okay, okay. So this is the complete. Okay. Yeah. Anything more will be multiplied, sir, or this is?
No, I think this is it.
Divided by 10 factorial.
Divided by 10 factorial. Okay.
Okay. Okay.
I think that's it from the week. Okay. Now, can anybody tell me what are random variables?
These are the variables that can take any number. Like for example, if we have 5 black balls and we are asked to draw 3 balls out of it, so random variables can take 0, 1, and 2 and 3 forms. So it can take 4 numbers as such. So this is what we call.
Okay. Yeah, this is right.
It is a function defined on the sample space.
Okay, this is also one way to say it, that it is defined on the sample space. And what are the outcomes you can get out of it? It can be any number, real number line, right?
Yes, sir.
Okay. Now, I think that anybody who has doubt about the contingency tables, like how to frame a contingency table?
No, sir, it was easy.
Like if you have to tell it in the notation wise, then any event inside this is actually A intersection B, right?
Yes, sir.
Means, for example, if I have to write it in words form, what does this 0.10 say? It says that the probability of the person being a female and not owning a smartphone, right? So it will come and, correct?
Yes, sir.
Is this okay?
Yes, sir. Just started general doubt. Like, may I know, like, for the quiz 2, what is the syllabus till, like, week 10 or week 9?
Week 8.
Week 8. Okay, okay.
Week 1 to 8. Okay. Okay. So when we are talking about, if you can see this part, this is a conditional probability statement we are talking about, right? So given that that person is a female, what is the probability that he or she doesn't what is the probability that she doesn't own a phone? Is this okay?
Yes.
Now if you say, if you see that in general, when we are talking about, my sample space was the whole thing, that is I was having both male and female, but when you said that it's a conditional probability, I'm already constraining my sample space to be just the females, and out of those females, what is the probability that that person doesn't own a phone? So my sample, in conditional probability cases, actually my sample space reduces. Okay.
Sir, a small doubt.
Uh-huh.
Are we going to have random variables in quiz 2? Isn't it week 9?
I'm not sure. If it is in week 9, then you won't have it.
Yeah, it's in week 9.
Just a second. Okay, so your week 8 is also just about conditional probability, independence, and Bayes rule, right?
Yes, sir. Bayes rule and total probability.
Sir, can you tell the weightage of quiz 2?
Weightage of quiz 2, sorry, there is nothing like weightage. It would be the whole syllabus is week 1 to 8. That's it.
No, sir. I mean week 1 to 4. How much weightage is there? Week 1 to 4.
5 to 8.
Week 1 to 4 would be of lesser weightage than week 5 to 8.
Okay.
Now, how much, that is difficult to say. Okay, yeah, that's my bad actually. So random variable, we're not supposed to discuss about it. I just got confused with the week 9 thing. Okay, so in this, basically in week 8 what we talked about is the conditional probability and Bayes theorem. So in conditional probability, as I was talking with about that, in normal probability and in conditional probability, the difference is that my sample space gets constrained. Over here, if you say, as I was talking about, if I have to say just the probability of female, if you have to say it just seeing the box, can you tell me what is the probability of female? Anyone?
44 by
44
100.
by
0.44.
0.44.
Yes, it is just 0.44, right? That is the probability of female. And if you have to say what is the probability of a person not owning a smartphone, then
10 upon 44.
24 by 100.
0.24.
So that is 0.24. Now it drastically changes when you say that what is the probability of same thing, not owning a smartphone, but given that that person is a female, then what it would be?
10 by 24.
Sorry?
10 by 24.
Yes, it would become
10 by
10.
24.
It would become 10 by 24, because at that time my sample space is no more 100, that is all person. It becomes only the 24 people, that those are females, right? And out of this, only 10 people have no smartphone, so it becomes 10 by 24. Is this clear to all?
Yeah.
Yes.
Okay, one more thing is the joint probability, marginal probability, and finding out the conditional probability. I think the conditional probability case we said, then the joint probability, just give me a second, let me see if ma'am has discussed about it. Okay, just a
No, we have just studied conditional probability.
that's what I was checking. Okay.
Sir,
So
this study material is available like with all this formula and all, because I have a
PPT of
problem
lecture.
remembering.
These are just
Sorry?
PPTs. These are
PPTs
the
of lecture?
lecture PPT. Yes.
They are in lecture.
Okay, thank you.
Okay, so as I was talking about that, how we are constraining our sample space. If you just check this question, I think where was this question? This part, basically that what it says that the sum of the conditional probability, the sum of a pair of rolled dice is 10. Okay, so when you are talking that the event is sum of the sum of the pair of rolled dice 10 is this event E. Okay, and the event F is that the first die is already lands on 4. So in general, when you are talking about, if let's say it was not been given, that is F is not given, it is just given probability of E, then what should be? I don't need the answer, just tell me what should be a sample space in that case.
36.
Sorry?
Dice will be 36.
Because of that, there can be 36 possible combinations of different numbers that I can get from rolling 2 dice, right?
Yes.
And now sum of a pair of rolled dice 10, then you have to find out all the cases. Let's say if you are getting 1 can't be there. If you're starting with 1, it's not possible. If you're starting with 2, it's also not possible. 3 also not. So you'll start with 4. So it can be 1 can be 4 6, the other can be 6 4.
6 4.
Another can be 5 5. Right?
3 upon 10.
Yes. So this way,
3 upon 36.
the main thing is that my sample space was 36. Now when I'm giving out this condition, that given that my first die lands on 4, I'm giving a restriction that already my event F has occurred. That is, what is my event F? It is that I'm getting F4, right? So when I'm getting F4 in the first die, then what are the possible cases of getting an getting the sum as 10?
4 6.
4,6.
Only one possibility, right? That is 4,6. Anything else is not possible. Is this clear to all?
Yes.
Am I audible, guys?
Yes, sir.
Okay. So now what I was talking about is that if you see the constraint sample space, one way to write it down is that probability of intersection F, what I was talking about earlier, right? That the root case for us. the root formula basically. And the probability of F, I can write it, note it down, that in how many possible ways I can get the first die as 4, and what are the possible options for the other one. That would obviously be that all the 6 possible, that is 6 by 36, that is individually the probability of F, and then probability of E intersection F says that I'm already getting a 4, and I'm getting, if I'm getting 4, then all obviously there is no other option to make it a sum of 10, and the second die has to be 6, so it becomes 1 by 36 in the top part, right? That is how basically we find the conditional probabilities. Now I think there was one question where there were a lot of doubts from this question, that the Zahir Khan one, right?
Yes, sir.
So if I have to solve it, if you have to say that, let's say there were
17 matches.
Okay, so take 17 matches. Let's say 17 matches, and
Ninth is the five wicket one.
Out of these 17 matches, what is the probability that the 9th match you analyze, that you are a match analyzer, and then in out of the 17 matches, let's say 6 matches are 5 in which he has got 5 wicket hauls, okay, or let's say he has won, let's say 5 wicket hauls, not complicate this, let's say he has won man of the match in 6 matches, okay. Now you are as an analyzer, you are analyzing all the matches, and then what is the probability that the 9th match that you will analyze, that is also that is his last man of the match that he has won. So how to do this kind of question? Anyone? How will you use conditional probability for this question?
So can you write this question again, sir?
So we can fix the last man of the match as our ninth position.
Just a second. The question says that Zahir Khan is a bowler and he has won 6 man of the matches, okay, and he has played in total 17 matches. You as an statistician, you are taking randomly choosing one each of the matches, and then you are checking that in that match did Zahir Khan win a man of the match or not. Now I'm saying that what is the probability that when you start choosing the matches, selecting the matches and analyzing them, what is the probability that the 9th match that you will pick up and analyze it, that would be Zahir Khan's last man of the match award.
Okay.
So if you see in this question, there is an underlying condition already given to you. What is that? That if I'm saying that in the 9th match, Zahir Khan should have the last man of the match award, right? Then indirectly I'm saying that before this 9th match, whatever the 8 matches we'll be analyzing, in that he should have won the 5 man of the match awards. Rest
Yes,
5 of the. Is this clear to all?
Yes.
Yes, sir.
So this condition is indirectly given to us. So that is what we will try to use. So let's say the first event can be that let's say probability of E, that in these 8 matches he is winning 5 of the man of the match awards. So how will you note that down? Anyone?
6C5.
Okay, 6C5. Yes. Then
into 11C. How many places? 8. 3. 11C3.
okay, and what
Divided
would be
by 17C8.
17C8. Okay. Anyone with any other answer, or all are okay with this? Anyone?
So would you explain how 11C3 came?
Okay. See, we are saying that before this match, before the 9th match, which we will be analyzing, how many matches we can analyze? There are 8 matches that we can analyze, right?
Yes.
And in those 8 matches, the condition I have to fulfill is that I will be getting 5 man of the match awards. So there in total there are 6 man of the match awards. So out of that I am choosing 5 man of the match awards, which would fall in this 5 means which out of these 8 matches, in any of the arbitrary 5 matches I will be analyzing. they have to be out of this 6 man of the match awards. Once you are done, then if I'm analyzing 8 matches and in out of those 8 matches, if 5 has to be man of the match awards, then how many has to be non-man of the match awards?
3.
3 matches. And in total, if Zahir Khan has won 6 man of the match awards, then in how many matches he did not win any of the he did not win man of the match award? Those will be 11, right? If he has played in total 17 matches.
Yes, sir.
So I have to choose out of this 11, only 3 matches to be analyzed in these 8 places, or in the 8 matches which I will be analyzing before the 9th match, right? Is this clear?
No, sir.
Which part you didn't get it?
First 65.
Yeah, 65. If you're speaking, I'm not. You're not audible.
Sir, I was disconnected in between. So, what was the question? Can you, if you have time, then can you repeat?
The question is simple, that we are talking about that what is the probability that if you are analyzing the 9th match of Zahir Khan, he would be that would be his last man of the match award. Zahir Khan has played 17 matches and there are 6 man of the match awards that he has won in total out of these 17 matches. That's it.
Okay, so what is the probability that 9th match?
The 9th match that we will analyze, that will be his last man of the match award.
Oh, okay, so how we approach this, sir?
So see that there is a condition given to us underlying this, that the probability if he in the 9th match he is winning the man of the match award, then indirectly we are saying that in the 8 matches before that will be analyzed before the 9th match, he should have won the rest 5 of the match awards, right? Then only the last man of the match can be analyzed in the 6th in the 9th match, right?
Right, sir.
So in these 8 matches, out of these 8 matches, I have to take 5 matches which will be the man of the match awards, and then the rest has to be non-man of the match awards. So in total, how many man of the match awards he has? That is 6, right? So out of those, I will be choosing 5 for out of these 8 matches. And if I have already chosen 5, then I'll be left with 3 matches to fill up for these 8 matches to be analyzed, right? Is this clear to all?
Sir, what is 6C5? We should choose 8C5.
I'll put it in a different way. Let's say man
It's
of
the
the
same
match.
doubt I also have. I don't know why 6C5 was taken. I'm confused there.
Is this grade assignment question, sir?
Yes, it's a graded assignment question.
Week 7. Okay.
These are the all possible man of the match awards available to us, right?
Yes, sir.
Okay, sir.
3, 4, 5, 6, 7, 8. These are the all the I will be analyzing matches, right? This can be match 1, I will pick up match 2, match 3, match 4, match 5, match 6, match 7, match 8. Okay, and then I will be getting the 9th match. Now these are not in any order. Okay, arbitrarily I can pick up any match and then I will analyze it. Okay, I'm just giving it for namesake that this is my first match that I've analyzed, this is my second match, third match, this way. Is this clear till this?
Yes, sir.
Yes, sir.
Now I'm saying that if this 9th match that I will be surveying or I will be testing, that would be his last match, that is the 6th one, then out of this 8 that I will be analyzing, I should have 5, right? So
yes,
I will put it this way, that I'm out of these 8 places, I want to choose 5 places which will be fulfilled, which will be filled by this man of the match awards. So how can you do that?
That should be 8C5, right?
No, I am how many places are to be filled? 5 places, right?
He's considering only for man of the
Yeah.
match awards.
Yeah,
So
yeah.
that's
5
the reason
places has to be
6C5.
filled. 5 places has to be filled.
And how
We
many
have
options do I have?
8.
8 not. I have 6 options. So his man of the match awards are 6, na?
Yes.
I have 6 man of the match options. Out of those, I will choose 5. Just tell me that how many. How can I do that?
Sir, why we are taking 6? Actually, we are having 8 matches, and
We are choosing matches, right?
We are
See,
not choosing matches. We are choosing.
Which all matches he is getting man of the match award.
sir,
We
can we think of these matches as like seats and man of the matches as like boys and non-man of the matches as like girls? Maybe that might help others visualize
Huh,
things.
but the thing is, it will get more complicated. Whatever you are coding for each thing. Okay, just tell me that this man of the matches are just normal. Okay, if you're saying
The
it
last man of the match he got on M9. That is
M9.
M9. It is written M8, I think.
It is M9.
M9. Okay. Then the rest of the 5 man of the matches, we have to find
distribute among 8.
Just okay, just
yeah,
consider
place
it.
among 8 matches, right?
Hold on. Just a second. Just think this places to be normal chairs. Okay. There are 8 chairs in which I am saying in these 8 chairs, out of these 8 chairs, in 5 chairs, I have to put this man of the matches. Let's say these are balls.
Correct.
Okay.
Yeah. So
These
that
are
should
just
be 8C5, right?
no, why it will be 8C5? I am just saying that out of these 8 chairs, I have to put in 5 chairs balls.
So we can say that we have
8 chairs
6
are
boys.
there, no? 8 chairs are there. You have
Consider
drawn
only
6
awards,
chairs.
6 awards, 6
My
awards.
8
So
chairs there, but we have to fill in 5 only.
my question is, I will fill only 5 chairs.
Sir, but we have to choose from 8, no? 8
No,
are there. We have to choose 5.
I am not choosing the chair. I am only choosing the balls. I have to choose out of these 6 balls any 5 balls. How will you do that? Tell me that.
Why
6C5.
are you we choosing from 6, sir? If we
Yes.
are having 8 matches, so there can be condition then in match 1.
So that order doesn't matter to us, right? That
We
is
are
what I'm
choosing.
that is what I'm saying.
We are choosing the the awards from the remaining 6, sir. That's why it's 6C5.
Remaining or in total only 6 man of the
Sir,
matches.
in total, yes, sir, in total.
Yes. For example, if you have done it, I think the first question what we discussed today, we said that there were 8 shirts or something, and 5 pants or something, and 10 t-shirts or something, and you have to select 3 out of this, right? Were you doing over there that 3C1 because you out of these 3 you were choosing one place where you wanted one shirt? You are not doing that, right? You were choosing out of the shirts because what you are choosing? You are choosing the shirt, not the positions. Similarly, over here we are choosing the balls, not the matches. That in which match I will have the man of the match award. For me, I am choosing that out in these 5 positions. I need out of the 6 awards. I need to choose 5 awards. That's it. So it would be just 6C5. Did you get it? Am I audible, guys?
Yes,
complete the
sir. But
explanation.
yes, sir.
Yes, sir,
Complete
still it is
the
not clear for me.
Yeah, I am also
Complete.
confused. That's why I am silent. So
No.
complete the explanation, sir.
The thing is, you are considering the matches. We are not considering about the matches. For us, we are choosing the awards. That's it. We are choosing. Just think it this way, that if the question given to you is that you have 6 awards, and you want to choose, let's say,
that I am clear. Like from 6 hours, if you are choosing 5 hours, then that can be done in 65 ways. That I am clear.
For example, okay, I'll just give you a different question altogether. Let's say you are going to your friend's birthday party, okay, and you want to take, let's say, 5 gifts for that person. From that person, for that person, and now you discussed with your friends, and your friend said that out of the 5 gifts which you want to take to the birthday party, make sure that you choose 3 electronic items from those 5 gifts.
Okay.
So, and you went to a shop and in that shop you find 10 different kinds of electronic items.
Okay.
So now how will you choose 3 electronic items out of this 10 gift that 10 electronic items are available for you? How will you choose 3 out of those?
10C3.
10C3, or will you do
That is
5C3?
clear.
No, but you are not doing 5C3, right? Because you had 5
No.
options to choose gifts. You are
Yeah,
ultimately
yeah,
taking 5.
understood. That I understood. Yeah, 10C3. In that case, 10C3.
Exactly. And then non-electronic items, let's say there are 20. So if you are
Yes,
choosing,
sir. But here in this problem, are we choosing
just
the awards? Or
yes, exactly.
are we finding out in which match? Okay.
No, that is what I'm saying from the beginning, right? That we are not concerned about the matches. We are concerned about the awards. Like for example, over
Yes,
here,
sir.
when you choose
What is
3, sorry?
What is the final question of that? What are we finding out actually?
No, in the initial part, what we are finding is that what is the probability that in these 8 matches, 5 of them are man of the match awards.
Exactly.
Okay.
So, okay.
It's very much confusing.
From 8 matches, probability of getting
When you were
amount of
talking, when you were saying that what is the probability that out of the 5 gifts you are taking, 3 are electronic items, how were you doing it?
that is, I am selecting from 10 electronic items, I am selecting 3 electronic items. No, that was available in the shop.
Same way over here, what is the probability that you are selecting 5 man of the matches awards from the 6 man of the match awards?
If I'm selecting
65
5,
will be
then it is
multiplied by what?
65. Then it is 65. If I'm selecting 5 awards from 6 of them, then it is 65.
Correct. And then you are left with 3 more matches because there are a total 8 matches, right? And there were if there are 6 man of the match awards, just I'm correlating over here. Over there you had 10 electronic items and 20 non-electronic items. Correct. And you have to choose 5 in total gift for your friend, from which 3 has to be electronic items. So you are doing it 10C3 into 20C2. Is this clear?
So can we say that we have 17 balls? Out of those 17 balls, 6 balls are blue and 11 balls are black. And we have 8 places to fill up, and we have to fill 5 black balls and 3 blue balls. So we had black balls as 6. So 6 choose 5. That would be 5 black balls and 11 blue balls. So 11 choose 3 would be our blue balls.
Yes.
And
Okay.
divided by the 17 choose 8 total balls. Total possible.
Whatever Chetan is saying, let's do it that way only. Just forget about any places also. Just forget about these matches. Okay. Just tell me that out of let's say there are 8 black balls and 5 blue balls, and you want to choose 5 balls out of them. Then what is the probability that 3 are black balls out of these 5 balls? How will you do that? It would be in general 8C3 into 5C2, right?
Yes, sir. Yes, sir.
But I am not bothered about which ball is first. The first one is black, or the second one is black, or the third one is black. I'm not bothered about that. In my bag, I should only have 3 black balls and 2 blue balls. That's it, right?
Yes, sir.
Similarly, in this case also, I'm not concerned about the matches. My only concern is that I will have in total 8 awards. Let's say, okay, just do it this way, that over here I'm saying there are 6 black awards, okay, and there are let's say 11 non-black awards. Is this clear now? This much? And then I'm saying that I want to choose 8 awards in total. So what is the probability that out of these 8 awards, 6 are black awards? How will you do that? sorry, 5 are black hours.
5 are, okay.
So how will you do that?
So it will be 6.
6 choose 5 into. There are 8 hours I have to choose, right?
Sir, 5 choose 6, no? 5.
Why 5 choose 6?
6 choose 5.
You cannot choose 6 awards or 5
From
or
5.
6 awards from 5 awards.
Now only we did for that case, right? That when you were choosing out of there were balls, there were 8 black balls and let's say 5 blue balls, and you have to choose 3 balls in total. How will you what is the probability of choosing 2 black balls out of these 3 balls? Were you doing 3C8?
Sir, that's what you are writing 6C5, sir.
Huh. Over here, how many balls do I have? Sorry, black awards I have
6.
And how many I have to choose out of this?
5.
So what should I write?
So 5.
65.
Okay.
Are you getting it?
Yes, sir. Then 65 multiplied by 11.
How many are left? I have to in total choose 8 black hours. Sorry, 8 hours, right?
11C3.
So if I have chosen 5 as the black hours, then non-black, then already I will have only 3 hours to be chosen, right? Because in total I'm choosing 8 hours. And I am saying that what is the probability that out of these 8 hours, my 5 are black hours. So if I'm choosing out of 6, 5 as my black hours, then I will be left with 3 hours, which I can choose as non-black hours. Correct. I have
Yes,
option 11 options. Out of that, I will choose 3. 11 choose 3. Is this clear?
Yes, sir.
Yes, sir.
And over here, we are not considered. We are not concerned about the position of the hours. That which one I have chosen as the first one, second one, this way. And in total, I have 17C 8. That are the total possible ways. So that would give me the first part of the question.
Okay, sir.
Yes,
Now,
sir.
once you are done with the first part of the question, that you have fixed 8 hours in this place, then what you are saying, that given this 8 hours, that is, if I have to say probability of that you have, just a second. If I'm saying that you have already chosen that the first there are first in the first 8 places you have already got 5 black hours, then now I'm saying that what is the probability, that is, let's say this event was, let's say A, then what is the probability that already this has occurred, then B will occur. Now what is this B? B is the event that in the 9th place I am getting the last award. How will you get that? Yes, the last award means last black award. In the 9th place I will get it, given that already in the 8th place, in the 8 awards that I have chosen, I have already got 6 black awards in total. So what is the probability that now again I will choose one more award, and that would be the last black award?
1/6.
1/6. Why 1/6? How many total possible awards are left with me? I have already
Only
chosen 8, right? And in total I had 17 awards. 17 awards I had.
1/9, sir.
It will be 1/9. Did others get it how it is 1/9? See, I had 6 black awards and 11 non-black awards. So in total, how many awards I had?
17.
17 awards I already had. Now I am saying that this is the condition that I am considering, that already the 8 awards I have chosen, out of this 5 have been chosen as the black awards. Correct. This is my the event A part. Is this clear to all?
Yes, sir.
So already 8 awards have been chosen. So how many I will be left with to choose from?
1.
No, 17 minus 8, right? That is
11.
Yeah, 17.
9.
Yes. So I can choose out of 9 hours anything. But I want the event B says that it should be a black one. So out of these 9 awards that I will choose, the black one is which one? Only one option is available for me, right? Because already the 5 before that I have already chosen the 5 black awards. So only one option is left for me, one black award, right? That would be my favorable case, and I could have chosen any 9 of those. So it is 1 by 9. Is this clear?
Yes, sir. Sir, it can be written as 9C1 multiplied by 9C1 multiplied by
1C1.
Sorry, 1C1 multiplied by 9C.
1C1 divided by 9C1.
Why divided by, sir?
How do you find the favorable cases? How probability? That is total number of favorable cases. Total number of possible cases divide. In the numerator it is total number of favorable cases, and in the denominator it is the total sample space. Correct?
Actually, sir, we are not choosing the non-black awards.
No, this is what we are choosing. We are choosing that probability of B given A. What is B? B is that in the 9th position I will be getting a black one. Means the 9th award that I will be selecting, that would be a black one. The condition A is that whatever 8 awards already I have chosen, out of those 5 are black awards already.
Yes.
Okay. So if you have already chosen 8 awards, then how many awards are left with you? There are 9 awards that are 9 awards are left with you, right?
Yes, sir.
Black award 1 is left with you, right?
Yes, sir.
In total, there were 17 awards.
Yeah, sir. I got it.
So already, my favorable case would be, that is the total number of possible cases, can be my all the possible 8 awards that I can select from. Sorry, not 8, 9. All the possible 9 awards I can select from, right? And
Yes, sir.
the favorable one is, because I'm finding for that only one black award. That is already only one award is left with me, because already I filled up 8 awards. 5 black awards already I filled up. So I'm left with only one black award that can be chosen, and I could have chosen out of these 9 awards anything. So that goes to my sample space. Is this clear? Should I repeat it once more?
No, sir. It's clear.
See,
so when it comes to this, in terms of man of the match and matches, if you explain, could you just once, if in a 1 or 2 sentences, if you can.
The only thing is, don't get confused with the order of the matches. I am not considering about that in match 1 I am getting award, or in match 2 I am getting award, or in match 3 I am not getting award.
Yes,
I am just considered about that in out of the 8 matches, 5 matches I should get an award. That's it.
Yes.
Is this okay?
Yes.
Okay. So I think after that what we had was that normal multiplication principle. I think this part we have already discussed, that if you have this probability of A given B, then I can write it probability of A intersection B divided by probability of B in general. So automatically I can write probability of A intersection B as probability of B into probability of A given B. Also you can write this part as probability of A into probability of B given A. This both are equivalent, these two. This is clear?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So from this also I'll just try to solve one question maybe from that graded assignment only. Just give me 1 second. There is one question I think about rain, storm and something this one.
That traffic one, sir.
I think so.
Yeah, question number 11 from graded.
During monsoon wala.
That one. Okay, so yes. just a second. So let's say we are saying that during the monsoon, it rains 1/3 of the days. Okay, 1/3 of the days it is raining. So let's say the probability of raining is 1/3, right? And it says that it affects students traveling to school. The probability that there will be heavy traffic on that rainy day is 0.5. So what we are talking about, that heavy traffic, let's say the event be H. Okay. So can you tell me what should be the notation for this? The probability that there will be heavy traffic on a rainy day is 0.5. So how should I write it in the form of notation?
Probability heavy given rainy day.
H by R.
It would be H by R, right? That would become 1/2 or 0.5. And then it is saying that on a non-rainy day, it is 0.25. So what does that mean?
H given RC.
Sir,
H
can you
given,
repeat the question once again?
this is, I just tell you. It is H given RC, this is 0.25 given, or 1/4. So it is said that the probability of raining is 1/3, and that affects students going to school. Then it is saying that the probability that there will be heavy traffic on a rainy day is 0.5. So on a rainy day, it itself is saying that there is a condition that given that it's a rainy day, what is the probability that there will be heavy traffic? Okay, and that would be 0.5 or 1/2. And then the question continues and says that and on a rainy day. So it is saying that the probability that there will be heavy traffic on a non-rainy day, and that is 0.25, what we have written over here. Okay.
Okay.
Then it is saying that if it rains and there is heavy traffic, the probability of a student arriving late to school is 0.5. So let's say late, probability of the event late be given by L. So how should I write this part? That probability
L given R intersection H.
okay. So probability of L given R intersection H.
H.
Is this clear to all? That is when I'm saying this, means it is saying that it is raining as well as there is heavy traffic. What is the probability that he will be late to school? Okay, this notation means that. Is this clear?
Sir. Yes, sir.
And that is, I think, 0.5. Okay, and if it is clear and there is no traffic, so it is saying that clear means R complement, right? And there is no traffic, that is H complement.
H complement.
This probability is reduced by 3/8. So still it is he's late, but so what would be this part?
0.5 minus 3/8.
It is reduced by 3/8, so it will be 0.5 minus 3/8.
0.125.
Okay, so it is whatever
0.125.
Okay, 0.125. Okay, now what we are trying to say is that if a person, if on a randomly selected day student arrives late to school, what is the probability that it was raining that day? So what are we trying to actually find out?
R given L.
Probability of R, that is if a student arrives late to school, then what is the probability that okay, so first thing is given it is late to school, so it is given L, and then it is raining, right? So this is what we are trying to find out. So our formula becomes R intersection L given by probability of late to school. Is this okay till this? Is it clear to all?
So all of the values have been given. Means I don't remember.
Yes, I'll try to find out all the values. Just give me a second. Till this, is this clear to all?
Yes, sir.
Yes, sir.
Okay. So now what we'll try to do is that we'll first try to find out the denominator part. That in what are the possible ways he can be late to school. So what are the possible ways do you think he can be late to school? That is probability of E. Let's just try to find out that part only over here. That what are the probable ways that he can be late to school?
It rains and heavy traffic. It rains, no heavy traffic.
Okay, just one point, everyone. I let everyone answer this. What are the possible ways? Anyone just tell me the first condition when he can be late to school?
Raining and heavy or traffic.
Okay, so first option, that it can be raining and heavy traffic and late to school, right? Is this part clear to all? What can be the second option? Anyone else?
So what we are finding,
Not raining, heavy traffic, late.
Not raining, heavy traffic, still late to school, right?
Hmm.
Not
Another
raining, no
another
heavy
option
traffic.
can not heavy traffic and late to school, correct? Other option can be not raining and no heavy traffic and late to school. These are all the four options.
yes.
Or anything else? So
Raining,
now,
no heavy traffic, that's not there. Raining
sorry,
and no heavy traffic.
this one, na? This part. Okay, na?
Yes, sir.
Okay. So now, if you have to find out for each, just I'll try to say for one part that how would we find out. Basically, we'll try to divide it into smaller chunks. Okay, as we are talking about here, that it is raining also, there is heavy traffic also, and he's late to school. So let's say we'll start it from the initial thing. Let's say it started raining. Okay, then multiply this with, it has already started raining. Now there is heavy traffic. Given that it is raining, it is heavy traffic. Then what happens, that given that there is raining, it is also there is heavy traffic, I am getting late to school. So these three things I have to find out to get this part. Is this clear to all? Is it clear, guys?
Yes, sir.
Okay, so similarly, if I have to do for, let's say, tell me for this part, how, what should be the formula? Anyone? How should I write this in the notation formula? Can you tell me?
Probability of
Given that it is
complement.
not raining,
Okay, probability of not raining, then
into
sorry.
probability that given that it is not raining and heavy traffic.
Means I didn't get it. Can you just repeat it once?
Probability of
Probability of R complement. This is what I'm
close
writing,
the
or
bracket.
this?
Yeah.
Okay, I'll
Probability
close.
of R complement, close the bracket, into. Now, given that it is a clear, so H C.
This is what you're saying?
Yes.
And then the last part would be?
Intersection.
R complement intersection H, this.
Yeah.
Is this clear?
Yes, sir.
Okay, so this is clear to all, that how to write the notation parts. Okay, about when you are having the this intersection thing. Now one more thing is that what we are actually finding out over here, if you see, this is actually what we are trying to find out is also the total probability, right? That what is the total probability that he can be late to school. If this is the question, then also if you find this, it would be the right answer. Is this clear? Means if my question would have been that what is the probability that he will be late for school, you would have done also the same thing. Just ignoring this part, you have to just find
Yes,
out
sir.
all these cases. That is the law, from the law of total probability, right?
Yes, sir.
Okay, now this way you will find it out for the different cases. Now in the top part, in the numerator, what do we have? I have probability of R intersection E, right? Sorry, R intersection L. Now how will you find out R intersection L? In the numerator, when actually what we are trying to find out, if you see this part, this we have to find out, right? This below part, now you can find it out, but how will you find out the numerator part, that is probability of R intersection L? Anyone? Guys, anyone how to do this part? Probability of R intersection L part. What does R intersection L tells me? Can you tell me that first?
He is late and it's raining.
He's late as well as raining. So in this, there are two conditions that can happen, right? One is that it is raining, it is late, and there is heavy traffic. Plus, it can be also that it is raining, it is it is late, and there
And
is
he is no heavy traffic.
no heavy traffic. These are the two possible conditions that can happen, right? Is this part clear?
Could you repeat, sir? The last part which you said.
When I'm saying that what is the probability that it is raining and he is late for school, there can be two possible cases, right? One is that it is raining, he is late for school, and there is heavy traffic also. There can be another condition where he is late for school and it is raining and there is no heavy traffic. Both the conditions can happen, right?
Yes,
Once you get this, again, how we were doing the earlier case, you can do it similarly. Correct?
Yes, sir.
Is this clear now? Means how to deduce the Bayes theorem or how to get this intersection thing. In Bayes theorem, it is just that normal thing, right? That is what we were doing like for over here. It is raining and late for school. This is actually Bayes theorem. That is R intersection L given by probability of L. This is what Bayes theorem is. This part is here the law of total probability, the below part, which we were actually finding out that how many possible ways he can be late for school, right?
Yes, sir.
And the top part we found out now that what are the possible conditions where it can be R intersection L together. Correct?
Yeah.
Okay. This is it, I think. Okay, there is one more thing I wanted to discuss. This is the last one, that how to go about that tree diagram. So let's say in the tree means if you have to do, let's say, tree diagram, let's say over here only we'll say there can be three conditions. One is if you have to put this thing into tree diagram only, that there can be either there can be traffic or there can be okay, let's say there can be heavy traffic and there can be no traffic, right? Is this okay? There can be another condition where I can say that there can be, what was the other condition? Heavy traffic. There can be rain. Just give me a second. Let's say this is the condition. Okay. So over here, first thing is I can say there is heavy traffic. There is no heavy traffic. The second thing is there can be rainy day. There can be no rainy day. The other thing can be that okay, this two only. The late for school doesn't will not put it over here. This two part is it clear to all that there can be heavy traffic, there cannot be heavy traffic, and there is rain and there is no rain. Is this clear? This part? These are the all possible options there can be, right?
Yes, sir.
Now let's say there is heavy traffic and this part that there is just a second. You put another part that is he is late for school and he is not late for school. That is if I have to put in this part late and late complement. Okay, he is late for school and not late for school. So there can be one situation that there is heavy traffic as well as there is rainy day and then still he is late for school. Correct. There can be another condition. There can be another condition that there is no heavy traffic and there is rain and still he is late for school. There can be another condition. See, the first thing is when you have so many conditions, doing it through tree diagram can also be complicated. Okay, that's why I intentionally started doing it so that it can be little bit. In some cases, you will see that doing it analytically is easy. Some cases you will see doing it through tree diagram is easier. So you have to be very careful.
So
Like
we
which
can
one?
we can draw a easier tree diagram for this one.
Yeah, how so?
You can take two possibilities for raining and not raining, R or R complement, R complement. And for raining, the probability is 1 by 3, and for not raining is 2 by 3.
The values you leave it. Just tell me the.
Yeah. And for raining, there will be two cases. There is heavy traffic and there is no heavy traffic.
Then again, you have to branch it out, right?
Yeah.
Means there will be 3 steps.
And
Yes.
There will be
again
heavy
for
traffic. Yes. Again, from this side also, you will
heavy
have
traffic, no heavy traffic,
and no heavy traffic.
and then they on converge to late.
Yeah, yeah. If you want to do it in 3 layers, you can do it for sure. Okay. But if you want to do it in 1 layer, then it will become very difficult. Then you have to be very careful that you don't miss out the numbers, because ultimately you will be multiplying all the numbers, right?
Yes, sir.
So for example, just to put it, what Chetan is saying, you can do it this way, that if you start with heavy traffic, there can be 2 conditions, right? What? Just a second. That you get heavy traffic or you get no heavy traffic. Now from heavy traffic you can get again rainy day, and there can be no rainy day, right? And from again over here it would be from non-heavy traffic, again rainy day, again non-heavy rainy day, and then again from this two you will get late. Over here you will not get late. Over here again you will get late and not get late. So ultimately it is that you are having 3 stages to it. If you want to do it, then you will get over here some probability, over here another some probability. You have to multiply it out, and you can do it that way also, not an issue. Okay.
Late and not getting late, it will be again branches will be there, right, sir?
See over here, if you see this one, that
8 of them will come.
This is one combination we took, that that there is heavy traffic and
rain and not rain.
Rain
and clear.
Start with rain and not rain.
There is heavy traffic, there is rain, and then you got late for school. Okay, this is one part. This part is heavy traffic, there is not rain, and then you are getting not late for school. Over here you are getting heavy traffic, not rain, and then again you are getting late for school. Okay, there will be 2 more cases, right? There will be heavy traffic, not rain, and still going late for school, right?
So we can do it like first we have a rain and not clear day, our complement, and for rain we have heavy traffic and no heavy traffic, and similarly for clear day, heavy traffic and non-heavy traffic, and for all 4 we have late. They all converge to late. Just to a single point. They all converge to late.
Okay, you don't want to put the non-late part.
Yeah, I don't want that.
Because that is not there in the question also, right? So yes, you can all consider this all to converge to one part. That also you can do. That is all going to the late part. Okay. So you will get all the branches, that is heavy traffic, yes, rain and heavy traffic, rain, non-heavy traffic, and late. All the possible options you'll get, because because for non-late we don't need it actually. We are not concerned about the non-late part. Is this clear to all?
Yes, sir. What is the answer?
No, I'm not sure about the answer. I'm just trying to say what should be the possible ways of solving the Bayes theorem questions. Okay.
Okay.
So in Bayes theorem question, there are 3 things to be taken care of. One is that if you have if you have this part, that is probability of A given B, then you have to find out this A intersection B part given by probability of B. Now this probability of B part is what we call about the total probability also. And this A intersection B can also be written in 2 ways, as I said you, what we were doing in the heavy traffic case, that either probability of A into probability of B given A, or you can do probability of B into probability of B given A, right? what we were doing over here, right? That is when you were saying that rainy and heavy traffic and also late, we are actually doing this, right? If you see this part, that is we were considering one part, that is probability of raining, then let's say raining, then we are saying that given heavy traffic it is raining, and then probability of raining intersection heavy late, correct? Now that doesn't mean that I can't write this way. Probability of heavy traffic also I can write first, and then I'll go for heavy traffic, then rain, into probability of rain and heavy traffic given late. Both are equally correct. Is this okay to all? Or anyone any doubt?
No doubt,
Anyone?
sir.
Okay. Okay, I don't think anything else is left out in this part. The conditional probability, we have discussed about the Bayes theorem. And yes, there can be some questions where in the top part, as I was saying, this part, if it is already given to you that these two events E and F are independent, then you don't need to do that. You can just do probability of E into probability of F, right?
Yes, sir.
Yeah, which is over given it over here, that you can directly do the probability of E intersection F part. Okay, I think that sums up the whole week 7 and 8. So in week 7, what we did was that it was basic probability, where we were talking about the whole sample space. And in week 8, where we are talking about is the conditional probability, where we'll constrain our sample space. And in that, you'll get some conditions. And the second part is the Bayes theorem part. And okay, one more thing I think I can add on over here, that when you are doing, let's say, there can be some cases that like for example, it is this thing is happening, what was the probability that this thing should have happened? I think in the graded there was one question related to that also, if I'm sure. Means for example over here, you can say that if the student has in the previous question what we were doing, then let's say the what is the probability that it was a rainy day, given that the student is already late for school. Okay, those kind of questions also you can be asked. So you'll do the same thing, you do the tree diagram. One more thing to keep in mind, that whatever you will have in the below part, a part of it will also be in the numerator part, so that can be used as a sanity check. That for example, if I have to do in the other part, like there were what were the conditions given to us, that is E intersection H intersection, let's say L, plus probability of E intersection H complement intersection L. This way we were there. So initially in the top also we had that same part, right? That is a probability of E intersection H intersection L. That is when either there can be it is raining, and there is okay, this was our rainy day. So this part is a rainy day and he is late for school. So there will be some common parts which we have already used in the denominator, in the numerator also. Okay. So that you can keep in mind that
Yes, sir.
are you doing it in the right way or not, just to keep a check on that whatever you have mentioned in the denominators, a few part of it would be in the numerator also.
Okay, sir.
Is this clear to all?
Yes, sir.
Okay, I think that's it, guys. We have discussed some 2-3 questions from graded. Okay. So that's it from week 8 and 7. That sums up. Tomorrow.
So what is the answer for that one? The other problem you have given?
That rainy day one.
No, not rainy day. The other one that you have given on the screen. That girl and boy, 2 selected.
The 4 selected, that one.
No. Just before there are one girl and one boy, two boys, two persons are selected.
4 boys are placed between 2 girls.
No, not that 4
That
boys.
one?
Latest.
No,
The
that
latest one you
question was different. That is not solved.
Which
What
question?
is it is not solved. Okay. I was just thinking the answer. It is on the screen that this question was pertaining to.
No,
what
that
is
question was different.
The question was introductory in an introductory statistics class of 40 students, the number of males. That is.
Sir,
the
actually,
answer
there was a question on your screen, and you are solving some.
Okay.
different
That was
question.
other question, and we were doing something other.
Yes.
Okay.
Yeah, right. That's what I'm saying.
Okay. No. We are not doing those questions. Okay.
We are not doing.
Okay.
Tomorrow we are having a session, sir.
Tomorrow there will be a session which either it would be completely 2 hours of PYQ, or it would be 1 hour of PYQ and 1 hour of mock discussion. Okay.
Okay, sir. And Saturday also we'll be having one more.
Saturday I'm not sure about it. If there is a session, it would be updated in the calendar by tomorrow.
Okay, sir. It would be nice if there is a session because
I'm not sure about it.
Okay, sir. Okay,
that the team would take a call on it.
Okay, sir. Yeah. Thank you, sir. Thank you so much.
Oh, well,
Thank you,
thank
sir.
you everyone.
So one question. For equally likely questions, if it is a biased dice, then how will it change the answer?
Okay. So there, I think I don't know if it was in assignment or practice assignment somewhere.
Mock test, sir.
Okay, I'm not sure about it. I'll just give you a very simple example. Okay, let's say it is said that you are having a dice, and in that dice you are saying that the probability of getting 1 is double than the probability of getting 2 in the die. Okay, and rest all the probabilities are same. So what do you think? What are the total possible outcomes for a die? Tell me that first. 1, 2, 3, 4, 5, and 6. Correct?
Yes, sir.
Now we are saying the probability of getting a 1 is double the probability of getting a 2. So what you will write it out? Then let's say the probability of getting 2 is P. Okay. And the probability of getting 1 is 2P, because we are saying it is twice the probability. It is twice probable of getting a 1 then getting a 2. Okay. Till this it's clear?
Yes, sir.
Okay. Now what we are saying, the other parts 3, 4, 5, and 6, it would be given something over there. Let's say it is already given, or if it is not given, consider them also as P for us. Now in this kind of questions, what is the trick you have to keep in mind? That whatever the possible probability values are given to you, just sum them up to all to 1. Okay. So over here it would become, for the first case it would be 2P, the second case it would be all P, right? So 1, 2, 3, 4, 5. So it's 2P plus 5P equals to 1. So it becomes 7P equals to 1, and P becomes 1 by 7. So what happens? This is now not a equiprobable case. So it is saying that probability of getting a 2, 3, 4, 5, or 6, these are all 1 by 7, and probability of getting a 1 is 2 by 7.
Okay, sir.
So
So
whenever
we can think of it in one another way, that the question says that probability of getting a 1 is twice the probability of getting a 2, right? So we can, to write a sample space, we can just double the amount of ones in that. So it would increase our sample space from 6 to 7. And
but the thing is, over here it is a small sample space, that's why you can do it. But
Yeah,
if you have a larger sample space, you can't do it, right?
I was just talking about the dice
Yeah.
question.
Correct. Obviously, that is what the ultimate thing is, that there are more number of 1 in your dice. That's why it means possible options. That's why it is more probable of picking up a 1, right?
Yes, sir.
So like for example, if you say in a bag, it can be twisted in this way also, that there are, let's say 4 black balls and 2 blue balls. Okay. So obviously the probability of choosing a black ball is twice that of choosing a blue ball, right?
Yes, sir.
So that way, so it ultimately it is that there are more number of balls, that's why it is more probable of getting picked up. And whenever you are seeing these things, that biased or unbiased, unbiased cases, just try to sum it up to 1 and you will easily get, means put it in the equation form and you will easily get the values for the unknown. That is the, what would be the new probables. Okay. And if it is equiprobable, then all the possible cases just divide it. It would become, that is like, for example, in a die, there are 6 possible outcomes, so it becomes 1 by 6. For a coin toss, there are 2 possible outcomes, so it becomes 1 by 2.
In biased
Sort
cases
of
also.
thinking like this as PMF.
Kind of, you can think it.
So for biased die or dice or coin, both of them we can use same 1 by 6 and 1 by 2 respectively.
For a biased die, you can't use 1 by 2, right? For example, I will say that there is double the probability of getting a head than getting a tail. Then what should be your probability for a head? Means it's a biased coin, and we are saying that there is a double chance of getting a head than getting a tail. Then
Is it 2
how?
by 3?
Sorry?
So
2 by 3?
2 by
how? Okay, one is saying 2 by 3. Any more answers? Or all will go with 2 by 3 only? Anyone, any more answers, or all are okay with 2 by 3 only?
So what was the question? My audio went out for a second.
The probability of means I'm tossing a coin and the probability of getting a head is double than the probability of getting a tail. So
Okay.
what is the probability of getting a head? It's a
2 by
biased
3.
coin.
2 by 3.
2 by
2. Okay. So anybody who didn't get it, how it is 2 by 3? Anyone? Okay, so that's it. So it would be like probability of tail can be P and probability of head can be 2P. So again, the same formula, if you use everywhere, you will be able to do the biased things always. So it
So
would be
always
3.
they will be giving us some condition for bias, right?
Exactly. There will always be something given to you if it's a biased thing. Okay.
Thank you.
Anyone, anything else?
No, sir.
Okay. Okay. Thank you, everyone.
Thank you, sir.
Thank you.
Yeah,
Thank you
good
so
night.
much, sir.
Yeah,
Good night, sir.
Thank you, sir.
Good night, sir.
Thank you very much, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.